Hello everyone, and welcome back to another Universe Sandbox 2 video, and today we're doing another idea commented by a fan, so many thanks to you. You know who you are for this idea. It's sort of like a little, or sort of like, I guess you could call it a part 2 to what we did about a week ago, where we put a bunch of blue stars in Uranus's orbit. Today we're going to be putting a bunch of the biggest stars ever into the Kuiper belt, so this is gonna get pretty crazy. And Sedna, I don't think you'll survive today, buddy. But yeah, anyways, before we get started, guys, just many thanks as always to all the people who have subscribed recently, because we're going up. We are so close to 1,300 now, so let's keep that up. Let's see if we can hit it maybe today. That'd be cool. But yeah, see if we can get it over the next few days. So yeah, it'd be pretty cool. But anyways, let's get into this. So the actual comment reads out: place the red giant sun, which I obviously have saved, the Rio Castafiria, which is the, I don't know if I said that right, but it's the yellow hypergiant star, the most known one, Antares, Betelgeuse, VY Canis Majoris, the best star, and UI Scuti, all in the Kuiper belt. I've actually got a few more I can add to the list as well, so let's start off with the red giant sun. So we're going to pause this simulation, we're going to slow it down. So, red giant sun, let's get you first. So it's not one of the biggest stars, but it's still quite big compared to what we have in the normal solar system. So we're just going to plot it as a still object, and we're going to put it near Pluto here. So actually we'll add in the Kuiper belt quickly first. So let's go ahead and do this. So there we go. So the Kuiper belt is about, I think it's about 32 AU onwards, because I know Neptune's orbit's about 30 AU. So I know this is a little further out than Neptune, I believe. So yeah, I think that's about right. And then it probably goes out to about, I don't know, 60 AU. I don't judge me on that. I don't know for sure, but we're going to put it there, and that will give us a giant asteroid belt in the outer areas of the solar system, just like that. So that's what we want. That works. So I guess we can. No, do we add the rest? No, we don't want to add the rest of the regular asteroid belt in, I should say. So yeah, we'll just leave it like the way it is. So if we go back to custom objects now, we'll get the red giant sun, place it right there. So let's go on still, put the red giant sun there. So that's the first one. The second star was, let's have a look here. Let's checking the notepad file here. So, red giant sun, Rio Castafiria. So that's the yellow star. So that's this one here. So we're going to go ahead and put you there. And I've also got this R. Liporis, which is a carbon star. So we're going to place that there. It's also quite large. So we're getting bigger, as you can see. Then Shai Shinaji. I've had this one for quite a while. We're going to place that in as well, because that's quite a large star. So we've got that one. Then we'll go back to what the comment was saying. So Antares and Betelgeuse, that's a nice easy one. So let's get those guys. Antares, where are they at? Come on, no, Antares is here. Yeah, there it is. So Antares, then Betelgeuse, which is slightly bigger than Antares, I believe. So we're going to place you there. Then we've got Canis Majoris, which is obviously my favourite. So I'm going to place you there. Then we've got UI Scuti. So I've actually got two more super hypergiant stars we can add. So NWL, I can never say it, Cygni, CYGNI, I don't know how to pronounce that, so we're going to place that there. And then I've got Westerland, which is also a very large, yeah, Westerland 126. So these are all the largest titans of the Milky Way, if you put it like that. Because these guys, compared to the red giant sun, these guys are absolutely huge. So yeah, won't be including any blue stars today. So we'll put, yeah, UI Scuti is still the largest. Westerland is bigger than Canis Majoris. I think it's bigger than this one as well. NWL, I just call it that. Is it 7.01 and this is 7.12? So yes, this is bigger than that as well. So yeah, poor old Canis Majoris is nowhere, not even in the top 3 anymore. So yeah, rip Canis Majoris. Well, it's actually going to blow up in 100,000 years time, I believe, as well. So yeah, that'll be pretty intense. Massive hypernova, that'll be crazy. It'll be cool to see though. So let's go ahead and place those there. So here we go. So the Kuiper belt is now covered, absolutely covered in super-sized stars. So the poor sun in the middle here, it's so small and cute, because look, if we look here, oh damn, we've got a lot of stuff here. So we've got, yeah, US Scuti, Westerland, then we've got NWL, then we've also got Canis Majoris, Betelgeuse, we've got that's Antares there, the R. Liporis, I believe that's how you said, Rio Castafiria, which is a yellow hypergiant star. We've got Shai Shinaji, which is a actually, I don't know what type of star this is. I can't remember. And then we've got the red giant sun, also, which is a red giant. So here's a red giant. Compare it to a red supergiant, which would be Antares here. So there's quite a big size gap. And then we've got the red hypergiants, like UI Scuti. So there's a big difference between red giants, supergiants, and then red hypergiants. So it's pretty cool. And then down here, we've got the regular old sun compared to its red giant counterpart. Like, look at this. So there's the sun and all the planets there. So pretty intense stuff. Now if we look here, damn, because if we go on the habitable zone mode, oh my, oh wow, oh my, look how blue that is because of the amount of stars. So planet 9, you may be far away, but you're still in the red zone, buddy. Damn, yeah, look at this. So planet 9 is in the red zone here, which is going to be, yeah, this is going to get insane. We've got Sedna here. Oh, Sedna is going to get just destroyed. So if we look here, how much sunlight is this guy receiving? Let's put it on realistic mode. Wow, look how bright it is here. Because like, that's what it should look like this. Like you can see there, it should be like a dark red colour, but look how bright it is. Or look how bright it is now because of that. It looks like Mars almost. Like, look at this. Sedna's meant to be like, oh, my Sedna's a dark red, my custom Sedna, but it's almost like the colour of Mars almost. We've got to check out Mars. So there's Sedna. And then planet 9, let's see how old the star, actually, no wait, from Sedna. Look how large these stars are. They're just covering the whole area. This is ridiculously crazy. So yeah, planet 9. Let's see how it's going here. So from planet 9, you can see all of the Kuiper belt now because it's all lit up by the stars. Planet 9 is receiving tons of sunlight, as you can see here. The whole thing is like white almost. It's almost like a Uranus blue there. That's looking pretty intense. Okay, next up we'll head to Pluto, since that's inside the asteroids here. So actually, it's sort of underneath the red giant sun, you can see there. So this is receiving light from a multiple different directions, which is pretty crazy. So you can really see the brown colour on planet, or not planet 9, Pluto now. Yes, there's some good old Pluto. Where's Neptune, my favourite planet? So let's go to you. Oh, it's Neptune's inside these stars. Wow, look at this. So the whole thing has got sunlight, apart from this dark spot here, which I believe is a glitch. So that is a very bright blue. Wow, it's meant to look like this, remember? But look at this. It's lit up so much by all these stars. It's literally gone like white almost. Okay, Uranus. I'm guessing this is going to be completely white since it is a lighter colour than Neptune. So, wow. That is look at this. It's meant to be looking like that. But this guy is gone completely white there. That's just because of the amount of stars lighting it up. Okay, Earth. Yeah, we'll check out on Earth will be the last because all the inner planets will pretty much probably be the same. So, here is Earth. Looking very weird here. Let me just quickly... Let's quickly just remove all the atmosphere and stuff so we can actually have a look underneath. Wait, climate. It's climate, isn't it? Oh, yeah. Wait, there it is. So let's turn those off. So there you go. There you can see. Yeah, that shadow here. This shadow shouldn't be there. I think that's a glitch. But yeah, as you can see here, no matter where you look on Earth, there are stars. So if we land on the North Pole here, right, the only dark spot, pretty much, we've got a few city lights, or not city lights, like a few building lights. There's no cities in the North Pole. So no matter where you look, there are stars. So we've got the red giant sun, then they slowly get bigger and bigger and bigger, as you can see here. Damn, this is literally insane. This is crazy. So if we just turn all that off, you can see all the asteroids around. So yeah, this is the only dark spots. You can see if we are on the actual surface, you can't actually see these guys. So that's pretty cool. But then you see they rise up. Got a few over there, and these guys are just covering the whole sky. So this is insane. But anyways, we're going to slow the time down to literally like less than a second here because I don't think it'll. I reckon these guys are going to completely get roasted like straight away. So Venus, we're definitely checking out Venus first because Venus is going to go insanely hot. So we're going to hit play and we're going to check Venus out. Okay, so as you can see, 400. If you look on the mini menu here, so there's wow, look how bright it is here. So it's 500 degrees. Just look at that number. Just look at that number. This is all happening in milliseconds. Look how quick it is heating up. So if we just take a quick pause there, we should start to see Earth increasing as well. So there's the regular sun. Well, I'm getting mixed up which one's which. So there's the regular sun. So Mercury also heating up in temperature, it looks like. Earth, 12 degrees. So it's only Venus that's getting affected so far. But I reckon once the milliseconds become seconds, then we'll start seeing some real differences. So let's keep going here. Wow, look how quick this is happening. Okay, so we're traveling now at 1.6 seconds. And just look at this. This is insane. Look how glowing it is as well. That's ridiculous. But yeah, there you go. 1,000 degrees now. That is insane. So, damn. Venus, I'm so sorry. What have we done to you? It's going to just, the surface is just going to completely melt here. Or if it actually works. Come on, surface. Come on, melt. What are you doing? There's not, I don't see any lava on you at all. Or any magma, I should say. Or is it? No, is it lava or magma? No, it'd be lava since it is not underground. Because magma is only... Or it's called magma when it's under the ground or inside a volcano, but if it's on the surface, I believe that's lava. It's pretty confusing, but if I'm wrong, someone's please correct me on that. But let's keep going here. So, okay, we're traveling at a few minutes now. Okay, so there, now you can see Venus is really heating up. So if we just put the atmosphere back on, oh no, the atmosphere's not even visible anymore. But yeah, that is insane. So yeah, keep an eye on that. Earth, 12 degrees. Yeah, we've got to turn off climate mode because climate mode always messes things up. So we hit play now. That's how hot Earth should be getting. So 400, 500, 600. Ceres, 1200 degrees. Because apparently it's not reflecting any light, which is pretty weird since it should be. Mercury, 1200 degrees as well. Mars, yeah, let's check up on Mars. I haven't looked at Mars yet. So Mars is going to be at 1100. But as you can see here, if we're going realistic, look how red it is. Like Sedna, like I said, Sedna and Mars are going to look similar here. But look at this. Look how bright that is. It looks like yellow almost. But yeah, when you have the atmosphere on, it looks more red. That's pretty cool actually. And they've got the clouds. So keep an eye on you. So that is just insane. I don't think the dwarf planets are going to be surviving this one. As we can see here, a lot of them are already just molten rock. So in Pluto, I guess you're gonna. Wow, Pluto is really close to that one. Oh, that's UI Scutty, isn't it? Oh wow, look at this thing. Oh poor Pluto. That is just. Look at it. Oh, it's losing material. Oh no, its radius is going down. It's losing lots of material. Oh wow, poor Pluto. Oh, more of them are heating up now. Earth is evaporating as we can see here. So poor old Earth. Yeah, all the water's gone. It's glowing hot now. Damn, this is insane. But we just got to wait till we speed this up more and the big stars start to collide, because that is going to kill everything. And maybe apart from maybe Jupiter. But remember, Saturn, in the last episode we did with this, Saturn didn't survive, I don't think. Or if I remember, I don't think it did. But yeah, Planet 9, 200 degrees, so it's lucky it's not too close, but it does reflect 30% of light according to this, so that's going to be pretty interesting. But what's going to collide first? I reckon UI Scutty is going to collide with the red giant sun or Westerland here. Well, this is ridiculous. We've got orbits here. They are just ruined. Look at this. I don't even know what's going on here. Apparently they're still. How are they still orbiting the regular sun? I don't know how that works, but yeah, this is a whole new level of insane. We've got 1100 degrees at Uranus here. Yeah, these guys aren't going to survive the novas, that's for sure. So you get the picture. These guys, all of the inner planets, outer planets, no matter where you are, apart from Sedna apparently, are just glowing hot. How's Sedna doing? 500 degrees, so yeah, Sedna will heat up eventually, but yeah, that is insane. It reflects 70% of the light it receives apparently, so that's pretty good. But anyways, now let's go to what we're really waiting for. So let's remove the asteroids, put trails on, and we're going to see what hits each other first. So we've got the smaller stars, we've got the larger stars here, so we're going to speed up time now. And oh damn, we'll turn off glow mode so we can actually see everything as well. So we'll turn that off. There we go. So now we can actually see all the stars. So, what is about to go down? So let's speed this up. So it'll probably take them a few years because they are massive distances apart. So we just need to keep an eye on how the stars move. Because remember, they are moving 4 kilometers a second and increasing there. So let's see. Okay, so we can't run it any faster just because of the amount of stuff that's going on in this simulation. But damn, this is insane. The sun has been moved. Look, the sun's moving now because of this, so that is not good. The orbits, oh my god, look at this. The sun is on the crash course with NWL right now, so that is not good. So yeah, here's all the objects. So looks like this is the fastest we can run it, honestly. Well, I guess we can go into the little secret setting here and quickly tamper with it. So let's turn that off and slowly, speed this up slightly. So let's have a look here. Okay, here we go. So it looks like, if we just look here, Haumea and Makemake, or Makemake, however you want to say it, they are on a collision with NWL here. So, yeah, these guys are getting dangerously close. Look at this. Oh my. They are just going to crash. Look, Haumea, oh, poor Haumea, and poor Makemake here. Damn. Oh, what am I going? I don't want to go to Antares. What am I doing? Alright, so, yeah, Makemake here. Damn. You are just glowing hot. So, look at this. Oh, poor Makemake. It's just going straight into the sun. Oh, he got destroyed. And Haumea's gone as well. Something's just crashed into UI Scutty here. That's a massive impact mark there. Pluto. Oh, Pluto is not surviving this very well. Look at that. Okay. So what's currently left? So we've got the Sun, Mercury, Venus, all the regular guys in the inner solar system. Planet 9 still doing fine. Saturn's still doing pretty much fine. So that's pretty crazy. Uranus looks like it's on the collision course of Antares here. And it is. But are the stars going to collide and kill stuff before the planets collide into the stars? Because it looks like Uranus is on a very dangerous collision. Whoa! Canis Majoris has just merged with NWL here. Look, it's disappeared. This could supernova at any point. Oh yeah, there you go. Oh, yeah, I called it. I knew it. There's no way two stars of that size would collide and nothing would happen. So now it's formed a black hole. So we've got a black hole in the mix as well. But yeah, it depends if the black hole's even going to be able to eat any of this, because I think the whole inner solar system is pretty much screwed at this point. They're not going to last, are they? Look, you can see like Earth here, the largest inner planet object apart from the sun. 118 kilometers. Like, they've just been reduced to nothing. So that is not good. Uranus. Don't know if you're going to survive this one. Oh, poor Uranus. Uranus never meets a nice fate in these videos of mine. But yeah, it's either going to get destroyed from the nova or it's going to crash into Centauri. So that's pretty crazy. Oh, whoa! What happened there? Oh, the carbon star, R. Leporis, I think collided with Antares there. Yeah, look, you can see some. I think there was some collision marks on Antares somewhere. Where are they? Oh no, that's just it shooting out stuff. But yeah, one of the stars here has disappeared. The other red star. So we had the red sun, the red giant sun. Then we had another red star that has disappeared. So I think that's collided with Antares. Yeah, it did. So that's not good. And maybe this guy will turn into a black hole soon. Okay, so Sedna. I really don't know if you're going to survive this, but this is insane. So we've got Saturn and Jupiter are all doing okay. The inner planets are all gone. So we've got Venus. No way. How? Just how? Venus is still around. There's no way. Surely. I don't know. How is Venus survived? No, Venus. No, there's no way. I'm going to delete that. There's no way that would have survived. Because Earth didn't survive. So, yeah, Venus wouldn't have gone. So we're deleting that. So, what we got next? Oh, more stars are coming. Oh, we've got a triple smash here. They're all going to... Oh, there's one nova. But the other two nova remnants going to collide. So, look at this. Betelgeuse is going to collide with Westerland there. I think the black hole is inside the Westerland, apparently. Yeah, it is. Because apparently putting black holes near stuff doesn't kill it for some reason, which is pretty weird. But Saturn is at 100... Is that... No, that's a... 11,000 degrees. That is really hot. But yeah, the two nova remnants are about to collide here. Betelgeuse and Westerland are going at it. The red giant sun's looking okay, actually. Okay, these guys are about to collide. Yep, they're going. But are they going to completely collide? Oh, those guys have all collided again. That's not good. So UI Scutty versus Westerland now. If Westerland doesn't supernova first, because it did just eat Betelgeuse there, so that's not good. Oh, there you go. There's the next nova. So we've got a nova remnant versus UI Scutty. It looks like Rio Cassiopeia just survived, collided with Antares there. Red giant sun's still chilling, doing its thing. So let's keep going here. The regular sun as well, just chilling. But let's see what goes on here. Antares is heading for Jupiter here, so that's not good. 40 kilometers a second. Jupiter's only traveling at 9, so it's gonna. I think this is gonna collide or pull Jupiter in. But here we go. The biggest two stars going at it right now, with a nova remnant, or with a black hole nova remnant inside, and we've got the red giant sun coming in for some of the action. So look at these two stars merge. Oh my! So Jupiter looks like it's being consumed. But apparently it's not being destroyed for some reason. That's pretty weird. Let's see here. Black hole is there, just chilling. But what's happening here? Are they going to collide or are they just going to go through each other? Come on. Westerland, you're going to get eaten. The red giant sun's coming in for some action. It's just gone through it. How does that work? Okay, red giant sun's going in. Like, what is going on here? Why haven't they collided? Like, right now we should be having this. But there you go. That's what's meant to happen. That's what we wanted. There you go, it blew it all up. Yeah, but that, in theory, that's what should have happened. There's no way those stars would have like done that and not blown up. So, we've got the regular sun, Rio Cassiopeia left, Antares, and we've got a black hole. We've got Jupiter, which has lost a bit of mass. Saturn as well, which has lost a bit of mass. So let's keep going here. Sedna, I don't know how you're going to survive this. I don't even know how Sedna is surviving. Planet 9 should be alright over here. Yeah, that's looking good. So, now we just got to speed it up and see what goes down. So, let's do this. It's going the fastest it can go now. So let's do that. Yeah, we're going as fast as we can. So, well, the fastest my PC will handle it anyway. But yeah, there we go. So, whatever you do not put these giant stars in the Kuiper belt. Bad things happen, as you saw. Damn. So even Jupiter here has been reduced slightly in mass. As you can see, it's now only 0.931 its original mass. So it's lost about 0.69 mass. So 0.69. So yeah, it's lost all that. So that's quite a lot of Earths. It probably lost tons of Earth in mass there. Wait, how many Earths? Actually, yeah, no, definitely lost a few Earths in mass, I'd say. So there we go. That is that. So it looks like all these guys are just drifting off. So the sun actually survived. But the red giant one didn't. But yeah, the sun actually made it out alive, which is pretty good. So if we just delete that now the stars or everything should just fly off in its own direction. And this dwarf planet survived as well. One of the far-out objects like Sedna. So here is our final lineup. So we've got Antares Nova Remnant. We've got the Rio Cassiopea one, if I even saying that right. Then down here we've got we've got the sun. So we've got the sun there. We've got Jupiter. Yeah, the sun's probably the only one of the original objects that hasn't lost any mass or anything. So you've got the sun, Jupiter, Saturn, Planet 9, all doing good still. Then down here we've got these little guys. So we've got Sedna and this one here, and then we've got the Radius. Then we've got the little black hole at the end. So here it is, 15 kilometers in size. This guy's as big as a pulsar. So there you go. Oh my god. Okay, yeah, but there you go. So you saw that. So that is good. So there we go, guys. So let's put trails on, and that is how everything happens. So yeah, hopefully you guys all enjoyed this video. Make sure you did hit that like button and subscribe for more. Help us on the journey to 1,300. Let's see if we can get it tonight, because that'd be awesome. But yeah, let's do it in our own time. Actually, I don't know. But yeah, let's see if we can get it tonight, because that'd be cool. But anyways, yeah, if you've got any ideas for another video, feel free to leave them down below, because I always read the comments and stuff. Yeah, make sure you all have a good day, and I'll see you in the next video. Goodbye. In the outer areas of the solar system, just like that. So that's what we want. That works. So I guess we can. No, do we add the rest? No, we don't want to add the regular asteroid belt in, I should say. So yeah, we'll just leave it like the way it is. So if we go back to custom objects now, we'll get the red giant sun, place it right there. So let's go on still, put the red giant sun there. So that's the first one. The second star was, let's have a look here. Let's checking the notepad file here. So red giant sun. Anyways, before we get started, guys, just many thanks as always to all the people who have subscribed recently, because we're going up. We are so close to 1,300 now. So let's keep that up. Let's see if we can hit it maybe today. That'd be cool. But yeah, see if we can get it over the next few days. So yeah, it'd be pretty cool. But anyways, let's get into this. So the actual comment reads out: place the red giant sun, which I obviously have saved. The Rio Cassiopea, which is the I don't know if I said that right, but it's the yellow hypergiant star, the most known one. Antares. Hello everyone, welcome back to another Universe Sandbox 2 video, and today we're doing another idea commented by a fan, so many thanks to you. You know who you are for this idea. It's sort of like a little, or sort of like, I guess you could call it a part 2 to what we did about a week ago, where we put a bunch of blue stars in Uranus's orbit. Today we're going to be putting a bunch of the biggest stars ever into the Kuiper belt, so this is gonna get pretty crazy. And Sedna, I don't think you'll survive today, buddy. But yeah, your juice, VY Canis Majoris, the best star, and UI Scuddy, all in the Kuiper belt. I've actually got a few more I can add to the list as well. So let's start off with the red giant sun. So we're going to pause this simulation. We're going to slow it down. So red giant sun. Let's get you first. So it's not one of the biggest stars, but it's still quite big compared to what we have in the normal solar system. So we're just going to plot it as a still object, and we're going to put it near Pluto here. So actually, we'll add in the Kuiper belt quickly first. So let's go ahead and do this. So there we go. So the Kuiper belt is about, I think it's about 32 AU onwards, because I know Neptune's orbit's about 30 AU. So I know this is a little further out than Neptune, I believe. So yeah, I think that's about right. And then it probably goes out to about, I don't know, 60 AU. Don't judge me on that. I don't know for sure, but we're going to put it there, and that will give us a giant asteroid belt